Welcome to Study Time, a televised home learning program produced by Rwanda Basic Education Board.
Hello, dear students of Senior 1 class. I'm so excited once again to be with you in this unit number 8, which is air composition and pollution. So mean the composition of air and pollution. I'm very sure these are not new words to you. So in the lesson number 1, we will emphasize on the determination of percentage of oxygen in air and uses of air as well. Dear students, I'm very sure you are ready with your pens and books. You'll be putting down some information that you need that will help you as we move along the lesson. So we'll just straight away look at the composition of the air. What are the components of the air? I'm very sure you are aware of the components of air. Even from your primary, you talk about the composition or the components of air. So air is a homogeneous mixture. Homogeneous means that the components in the air mainly are in the same state of matter. They are in gaseous form, and the components of air does not vary much except for the moisture and pollutants. So one of the most components of air, as you are aware, is the oxygen gas. Can you name some other components of air? I'm sure you know them and you can name them as well. So other components include nitrogen, it includes carbon dioxide. I'm just mentioning the main components. And some dust components and noble gases, some small percentage of the noble gases. But as I said earlier, we are just going to emphasize on the oxygen. So as you know, we need oxygen for burning and respiration. Actually, when we talk about burning and respiration, it is almost the same. Why? Chemically, they are similar because they all, in burning, a substance combines with oxygen. So you all know that burning, for burning to take place, you need oxygen. In absence of oxygen, burning cannot occur, cannot take place. Similarly, respiration, which is very important because we have two forms of respiration. If we are talking about respiration, it is the breaking down of food in the tissues, in the cells, to provide energy. So without the oxygen, respiration cannot take place. But we are talking about aerobic respiration because we have two forms of respiration. We have anaerobic and then we have aerobic respiration. So respiration only takes place, the aerobic one, that involves breaking down of food to produce the energy that we use for all other activities. So oxygen is important for that. Can you mention other uses of oxygen apart from that? Apart from burning and respiration, can you mention some other uses of oxygen? In a few seconds, just put them down. I'll just give you some few seconds, and then you put them down. If you put down those few uses, then we can even proceed and look at these are the components that I've been mentioning. But these are the main components. As I mentioned earlier, there could be some other components including the dust particles, including methane gas. But when we look at these are the main components. Nitrogen, as you are aware, it contains a bigger part. This is the table showing how the components are distributed in air in terms of percentage. So we have the oxygen, which is 20.1, but in some books they mention 21. That is okay, because 20.9 is approximately equal to 21. Nitrogen, you have 78.4, and carbon dioxide, you have 0.03, and whereas inert gases contributes to 1%. But it is important to note that these are not the only components of air. As I said, you may find there some other dust particles, methane gas, and other substances that also can come as components, but they are pollutants in that case. So when we talk about the inert gases or rare gases, or they are commonly known as noble gases, they contribute 1%. This is where we have helium, we have neon, we have argon. So all those contribute 1%. So these are the components. I'm very sure you can remember this. So you need, even from your primary, I'm very sure you have this information. So this is a small part of what we are supposed to look at. So we'll also proceed and look at how the percentage of oxygen, the percentage of oxygen, which is the most active part of air. How can we determine the percentage? How can we determine the percentage? Probably, I'm sure when you go back to your schools with your teachers, you will be able to do this experiment with your teachers. But here, we are just going to go through this experiment and how this experiment is carried out. So we'll look at the theoretical part of this experiment, and then look at the materials required, look at the procedure, look at the results. If the results are obtained, how do we treat the results? That is very, very important. So among the materials that we need to determine the percentage of oxygen in the atmosphere or in air, among the materials that we have syringes. You know syringes. These ones we use for the doctors and nurses use in hospital for injections. So we need 2 syringes. Then we need hard glass tube. I will have to emphasize hard glass tube, hard. I will tell you why we need a hard glass tube. Then we need a glass wool which is made of glass. We need a Bunsen burner. Of course, the Bunsen burner is for heating, and the matchbox that will provide the light, and heat. Procedure, how do we go through? How does this process take place? So you'll have to press a small amount of copper tannings. Actually, among the materials that we need the copper tannings or copper metal. The copper tannings are small particles of copper. Or you may need copper powder, copper metal, but in form of powder. So when we talk about the tannings, they are small particles. You'll have to put them in a hard glass. We're just going to see the arrangement. But I just need you to have this procedure in your mind before you look at the arrangement of the apparatus. The small amount of copper tannings, you'll put it in a hard glass. Then put glass wool on both ends of the tube. So this tube must be open, both ends. So if you have the tube like this is a glass. This is a chalk, not the tube. I'm just assuming. This is a glass. If we assume this is the glass, the tube must be hard. Of course, the tubes have hollow space inside. So it is open on this end, and it is open on the other end. So you need to put the glass wool on both ends. That is after when you have put the copper turnings. 2, you label one of the syringes that we said we need them. You label them, one of them you can label them A, and another one you label it B. It doesn't necessarily you have to label them A and B. You can use any other letter for you to remember. Then make sure you remove all the air from this syringe by pushing the plug. So you know the syringe has the plug that pushes the medicine into the needle that will push it into the skin. Now, by this time, we don't need the needle. We only need the syringe, the other outer part. And then you push it so that you remove the air. You make sure there is no air inside that. Fix it tightly to one of the glass tubes. So after remove, make sure the air is removed. You fix it on one of the tubes. And label the other syringe you said you have already labeled them. Then pour the syringe of B out to 100 cubic centimeter mark to fill the air within that syringe. So B must be pulled to that prong must be pulled to 100 cubic centimeter. So that means you leave the space inside. This is what I'm talking about. This is the tube here. This is the tube. This is the syringe, which we said you have to pull it apart to 100 cubic centimeter mark. So this space is empty. That means there is air. And that air contains oxygen. That is what we want to determine its percentage. And this one, you have to make sure this prong is pulled or pushed to the end so that there is no any air inside. Then you hit this one, the tube, strongly. That is why we need a hard glass, because it has to be heated strongly. If the glass is not hard, then it will break. So you need to heat it strongly. So when you heat, because you are heating these copper turnings, a reaction will take place. That means some of the air here, we are just looking at the air here, combining with copper to form the copper oxide, copper 2 oxide. Copper 2 oxide is black, and the copper turnings are brown. That is how you will tell, because this glass is transparent. So you should be able to tell that the reaction is going on by the changes that you are seeing within the glass tube. So you have to make sure you are looking at the changes that are occurring. Then you will see the changes taking place. I said copper turnings is brown. It is brown. So you expect the copper turnings to change to black as the reaction takes place. And how does the reaction? That reaction is using oxygen. Copper does not react with anything else. It reacts with oxygen when heated. And this oxygen is not coming from anywhere else. It is coming within this here, this space. So when the experiment continues, some of the space here, the volume of the gas here will reduce. You started with 100, now the volume reduces. What does it mean? It means that the reduction in volume constitutes the oxygen that has been used for burning that copper turnings. Copper is brown. I just want to remind you that. Copper is brown, but copper, when the copper combines with the oxygen, then it will form another substance, which is copper 2 oxide. That copper 2 oxide is black. So when the copper turnings, when you don't see any change taking place, then you can stop the reaction. Heat the tube, copper turnings very strongly, pass the air over by slowly pushing the plug, syringe B, to and fro several times. That one I've mentioned it to make sure that there is no air entering. So you keep on pushing it up and down. when there is no further change in the volume of air, I said after some time, the volume of the air that you started with, reduces. Why does it reduce? Because part of it has been used in the reaction. You record the volume of air left in that syringe. You record the volume of air left in the syringe. B, remember, what is the color and name of the solid residue in the tube? Did I mention that one? Yes, I did. I mentioned that. I said the color will be black. Copper tannings will be, copper tannings is brown. So after some time, the copper tannings, which is brown, will change to black. And what is that black substance? Did I mention that one? Yes, I mentioned it. I mentioned that substance as copper 2 oxide. So you need to remember that. Then you calculate the volume of air used up in the experiment. You calculate the volume of air used up in the experiment. You have the volume that you started with. You remember, what was the volume that we started with? Do we have it in our experiment? Yes, we have it in our experiment. We started with 100. And we said after some time, when you hit strongly, after some time, that volume will have to reduce. What causes the reduction? The reduction is due to the fact that part of the air, which is oxygen, because we said oxygen is the active part of air. So that active part of air will have been used in the reaction. So this is how we treat the reactions. Rather, the results, I beg your pardon. So in the calculations, we have the initial volume of air in the spray, in the syringe, which was B. We started with 100. Final volume of air in syringe B, you start now, has reduced to 79. So what is the volume of air used? So the volume of air, remember that volume of air constitutes oxygen. That is what I want you to remember. It is not the air that has reacted, no. Air constitutes other substances as we mentioned them from the beginning. The nitrogen, the carbon dioxide, those ones are also mixed there. But they are not the ones now reacting. It is the oxygen. So when we say volume of air used up, it is the volume of oxygen that was used up. So it will be 100. This 100 is the volume, the total, the initial volume that we started with, minus the final volume. And therefore, the volume of oxygen that will be used is 21. These are assumed values, my friend. So when you go back to school, you may not get exactly these values. You may get some values probably close to this, or slightly above or below, but close to this, but not exactly this. So I just want to inform you that these are assumed values because we are just looking at the theory part. Practicals have some errors here and there, and those errors are okay. Percentage of air used, now we convert that volume, 21. So it will be 21 over 100 times 100. That is the volume of oxygen over the initial volume of air times 100, which would be 21%. This means that only 21% of air was used up when copper was heated. So I said you may not get exactly. I just want to repeat this so that when you go back to school, don't get confused. That we saw somewhere on TV that the teacher was saying we have to get 21. No, you will not get 21 as we have here because these are assumed values. I said and emphasize that you will get some values very close to this, not exactly this. So that was method number one. There is another method that we can use. In this method of determining the percentage, we're using oxygen and using any other metal. So here, this is the arrangement. You'd use iron filings. That is one of the examples of the metal, because iron combines with oxygen. Then you have the bullet. Probably you could have looked at the bullet. If you have bullets at school, I am sure you must be knowing this. Then you fix iron filings on this bottom part. This is the iron filings. And then you leave some space. So you have to leave some space here. This is air. Now that means there is air here. This one will be closed, remember, so that you don't allow any other air to come in. So this space here means there is some air inside. And then this is water. How does the experiment go? Let's see. You press wet iron filings at the end of the bullet. You have seen how it is. This metal, this is a metal, so it may not be easy to fix it there. So you can use the Vaseline. You can use Vaseline, or you can use porcelain clay to make sure you fix it there and it sticks on the billet. Use a clamp to hold the billet vertically in the trough of water. That billet is very small, so it cannot, if it is very small, it cannot keep hanging in space like this. It has something to hold. You need something to hold it so that it remains fixed in the trough of water. Measure and note the starting height of the water level in the billet. You have seen there is some space where there is water and where there is oxygen. So you leave the apparatus to run for weeks. This experiment takes weeks, not only one. You can even leave it for 2, 3, 4 weeks. You leave it to run for those weeks. Why? This is a rusting reaction. You expect iron to combine with the oxygen. In presence, there is air. Remember, inside, the air contains oxygen and there is water. That is why the water is very important. And we said the iron must be wet to ensure that all the conditions for the reaction, which is the reaction to take place, are present, or the conditions for rusting are present. You measure, after some weeks, you'll have to measure and note the final height of the water level in the bullet. You don't expect the level of water to remain the same, much as the level of the air to remain the same. After several days, we are now looking at the results. After several days, the water will rise up in the bullet and reach constant level as the iron filings will react with all oxygen in the air to form iron 3 oxide, which is rust. So after some time, when you look at the diagram, after some time, the water will have to rise a bit. From this initial, it rises. What causes the rise? It means that the water will rise because there will be some vacuum created. The volume of the air has reduced. I think it makes sense there. When the volume of air has reduced, where does the air go? The oxygen part reacts with the iron here. So we expect the volume of air here to reduce, and that's why the volume of water increases. Water is not blue, by the way. Water is colorless, but I just used this blue color to show the level of the water. So that is what you should always know. So we are saying the water level will rise to replace the volume of oxygen lost during the reaction. So assuming the original water level was at 15, then now the final volume will be 12. That means, what does that mean? It means that 3 cubic centimeters has been used up. That is the 3 cubic centimeters of the oxygen, because what raises is the same as what reduces. This is the calculation. So you'll have the volume of oxygen used up over the total volume of air at the start. Then you can get the percentage of air. Importances of air, we have so many importances. Carbon dioxide is a waste product, very important to express. Carbon dioxide, a raw material for photosynthesis. Nitrogen air makes it inert, and you remember nitrogen can be used to make even some explosives. It is converted to other substances and other fertilizers. Mountain climbers and deep sea divers carry oxygen in tanks, because as you go higher or deep in the water, there is a reduced amount of oxygen. So you need to carry your oxygen. That is what we are just trying to show. Then artificial oxygen in hospitals during this period of COVID, I'm sure you should have looked at this. So in hospitals, patients who are not able to extract oxygen from the oxygen, so they will have to use that artificial oxygen. And then we have carbon dioxide for fire extinguishers when the fire has gutted either a building or any place. You need the fire extinguisher. That is carbon dioxide, remember. Moving air or wind can be used to rotate turbines for electricity production here. So the amount of energy can be generated, that wind energy can be converted into electrical energy. The air in general is used to inflate tires of vehicles with air. Vehicles make transport easy and fast. You said when there is no air here, so the vehicle cannot stand firm, and therefore you need the air to inflate those tires for easy movement and transport, which becomes a bit faster. Thank you so much, dear students. I hope to see you in the next lesson. This is what we are supposed to look at: the uses and the percentage of oxygen in the air. Thank you. Bye-bye.